So, take it away, Chris.
You bet. What we have is a basin in central Wyoming where we believe that there is cold air damming occurring. One of the issues we have is that it's not a classic cold air damming situation, but we do have it going on, we believe, and that is that when we have a cold frontal passage from the north, we have it bank up here against the Wind River Mountains, almost orthogonal, so we have very good upslope, and that's typical for places like Lander to see snowfall of 100 inches a year. We're out here in the central part of the basin. Riverton might only see 30 inches of snowfall a year, so we know that upslope dynamics are certainly at play. What makes this unique, though, with the cold air damming situation is that we can see some fairly high snowfall amounts out in the center part of the basin, and that's usually in a southwest flow aloft. So we have an overrunning situation. We actually kind of stole this from the Comet program. We did give them credit, courtesy of the Comet program, but where we have the flow and the damming up against the northeast slopes of the Wind River Mountains, and then the southwesterly flow overtopping that and then causing some heavier precipitation out in the middle of the basin. In one of the case studies, actually, we had snowfall out upwards of 12 to 18 inches out in the middle of the basin, where up against the foothills we had 30 inches of snowfall, which was greater by about 50% than what we were seeing in the mountains. So just an example of how that can really have some significant impacts. Our forecasters are pretty adept at least putting those kinds of higher amounts against the foothills, where we sometimes get surprises out in the basin. But when we have a situation with this overrunning, with this cold air damming at the surface, we're seeing some unusual amounts. When you're talking about 28 inches a year at Riverton, and in one snowfall again you get 12 to 16 inches. That's significant, to be sure. So we want to go back and take a look at some situations possibly with a barrier jet developing along the northeast slopes. We certainly see the northeast winds decelerate in the cold air damming, but we're wondering if we're also seeing some turning parallel to the mountain barrier, and in fact getting a barrier jet. In order to determine that, it's difficult with the radar. The radar looks at that at a perpendicular angle, so we can't exactly get a good measurement of those velocities along the barrier. But what we want to go back and do is actually take a look on a close-up of, we have a protrusion right up against the mountains here where we see some pretty significant snowfalls usually, and we believe that possibly is the barrier jet creating another upslope maximum right here at the mouth of this canyon called Sinks Canyon. So we need to have basically a mesonet all around this area on both sides of that barrier, of that protrusion, to see if indeed we're having some enhanced snowfall from a barrier jet and perhaps downsloping on the other side of that. So that's cold air damming in a central Wyoming basin rather than on a coastal plain or along the foothills of the Rockies in Colorado. So
are we talking on a more local scale than most of the cold air damming you think of on the East Coast?
We would be talking on a more local scale. In this case, we might be talking only 20 to 30, at the most 40 miles off of the mountain barrier, and only in about a 40-mile width region. So talking about 40 by 40 at maximum, where we could be talking about perhaps a couple of states worth, certainly along the east slopes of the Appalachians. So even the foothills of the Colorado Rockies can be extend out 30 to 50 miles and then several hundred miles long, or at least a couple of hundred. So it is in a more localized area. It's a unique basin in that it truly is enclosed on all sides by higher terrain. So we picture it almost like a pool, where it literally is getting, as it comes over the Owl Creek Mountains, it pours into this pool and almost can level out in a typical Arctic air mass. But in this cold air damming, we'll see it get deeper, where we have inversions here upwards somewhere around the 625 millibar level, somewhere probably 11,000 feet MSL. So not as tall as the barrier, but certainly much deeper than what we normally would see in just an Arctic cold air outbreak.
You're talking about people who already expect snow to some extent, right? I mean, you're in a region of the country where snow's, it's not a real transitional area, right?
No, it's not. Especially as we get into the midwinter, it's snow. We don't have to worry about mixed precipitation or phases.
So in this case, you're looking at an enhancement of the snow, but not necessarily a change in the snow line.
Correct. No, not at all. Matter of fact, even in these cases, which both of the ones I picked happen to be, we see this a lot in the fall and then in the springtime again, because we have these much deeper southwest cutoff lows that are pumping up southwest flow. But even in these situations, it was snow. We do see certainly some events where we have lines even between the towns of Lander and Riverton, which are basically at the same elevation, but Lander being close to the foothills does enhance that and help that precipitation change over. But in both of these cases, it was snow. It was pretty much, as soon as the front went by and we got some precipitation, it turned right to snow and snowed the whole time.
Now, your poster is unusual in that it doesn't look like it's got a lot of models running simulations. So I got to ask you, I mean, how do you look for this as a forecaster?
Well, good or bad, it's not something that you wouldn't find out of the ordinary. I mean, we know that we get this southwest flow. It's very moist. It's overrunning this cold dome. I don't think we think about it, though, as cold air damming. So what we see is we'll have a lot higher amounts forecasted near the foothills. That's expected. But it's out in the basin where we can get burned. So what we're trying to do is we do run a local WRF model. We did not have it present for our 2003 event. We did have it present during the 2008 event. And you can actually start to see some of the downsloping and certainly some enhancement out over the basin. I chose not to use those just because they weren't fantastic examples, but it is something that now that we're more, I think, attuned to looking for the cold air damming, we'll be looking for more events like that and then capturing some of that model data and sharing with new forecasters who, of course, come to us from, we have one arriving from Alaska, we've had people come from as far away as Virginia. So it's a new world for them. And then those of us who have worked here for even a decade, it's always good to find out more things that you can go back and say, hey, when you see this, make sure you bump the forecast out in the basin too. Don't worry, don't think just along the foothills, think out in the basin. And the other surprising thing is when we're doing our graphical forecast, we're traditionally, if we have 2 feet forecasted in Lander, the natural progression would be to have 3 or 4 feet in the mountains, when in fact in the cold air damming case, we may have 2 feet in Lander and less in the higher terrain. So that's another thing that we need to be tuned in just to give a better forecast for those who are venturing into the mountains as well.
That's great. Well, thanks a lot, Chris.
Thank you, Jeff. I appreciate your time.